question, Devin, before me too, I can post this.
Alright, hi everyone, I'm doing the Rankine cycle report. Next slide. Alright, so just a quick overview of how it works. You're going to start at point 1, you're going to pump, you're going to put work in and pump water into your boiler where it'll be held at a constant pressure, and you're going to add heat to bring it up to steam, and it's going to go to your turbine, and you're going to give all that heat and pressure to the turbine and get some work out, and that'll become electricity. And then it's going to go to a condenser to get all that heat out of your working fluid, and then it'll just repeat. But in our case, we don't have the working fluid doesn't keep going in the cycle, it just condenses and goes into the air. Excellent. All right, so just basic procedure of how it went down. Basic PPE, glasses, closed-toed shoes, pants. Follow the instruction manual and make sure not to overload the generator or go beyond the operating parameters of the equipment. So the way that the experiment worked, we did a basic safety check, made sure that none of the propane was leaking, anything like that. Emptied out all the old boiler water and then refilled it. Did a pre-start and got the boiler system up to pressure and temperature. And then brought it to steady state and just let that run for, it was supposed to be about 10 minutes, but it ended up being only like 5 because we had the low water and it shut off on us. And after that, you just shut down the experiment. So this is some of the basic data that we got during steady state. It's not very interesting on its own, so we can just go to the next part. So this is the main stuff that we're looking for. So the heat flow out of the boiler, the work rate of the turbine. So this is how much work that the turbine was gathering from the steam. And then from there we calculate the efficiency of the generator. I got about 3.29%, which is similar to what Lewis got. And then the mass flow rate of the system was 0.00337 kilograms a second. Also don't know how correct that was. I think it was right. And then for my total thermal efficiency, I just calculated it based off of how much energy we got from the generator and how much energy we put in through the propane, just going off basic mass flow rate from the fuel flow rate of the propane and how much energy propane has per density. And so I got a terrible number, 0.1%. I would not use this steam Rankine cycle to power anything. Probably couldn't even charge your phone. Here's basic raw data charts. As you can see, everything stayed pretty much steady as it should have, and until we got up to about 300 seconds when the fuel was cut off because we ran to low water. So yeah, that's the boiler temperature. It stayed pretty much steady. The boiler pressure, I think that it started to drop at the end because we were running out of water in the boiler. Here's all the turbine data. You can see it all stays steady as it should. And then once again, the inlet temperature is dropping down, which we could expect because the boiler temperature was starting to drop, but it was close enough to where it can be assumed steady. And then this is the generator data, the voltage and the amps. We're keeping it steady. Yeah, that's pretty much it. Okay, so conclusions. Don't let your water level get too low because that's what stopped us from being able to run it the full time. So it's definitely very important. Also, we didn't have the same current and amp readings on the computer as we did on the instruments. So we're not 100% sure on the efficiency of that. Just basic conclusions. This experiment is very ineffective, but that is not the case in the real world. We didn't have, our working fluid wasn't being cycled back into our system, so we definitely had a lot of losses there. And then I just don't think it was a very effective generator or turbine. So we lost a lot of our efficiencies in that case, because the Rankine cycle is one of the most efficient cycles and one of the best in thermodynamics. That's why it's used for almost all of our power generation when it comes to nuclear energy, coal, natural gas, all those power stations all use the same cycle, just a different form of fuel to heat the liquid. And, that's it. Any questions?